Okay, so question number 4. Why do we believe that the valence electron of calcium and potassium resides in the 4s orbital rather than in the 3d orbital? Okay, so to answer this question, let's first find the electron configurations of both calcium and potassium. So to find the electron configurations, we need to divide our periodic table into the different orbitals, s, p, d, and f. So after dividing it, we get something like this. So the s orbital are the first two columns here, including the helium. And the p orbital is this green section. The d orbital are the middle transition metals. And the f orbital is just the last two rows, the lactanides and actinides. So calcium is found here. Atomic number is 20. And if we start from hydrogen and move left to right across the periodic table, we need to write the row number followed by the block letter. And in the superscripts, we can show how many electrons are in each orbital. So starting from hydrogen, we write 1s, and there are 2 electrons in the 1s orbital, so we put a superscript of 2. And then down to the next row, we have 2s, 2. And then when we get to 2p, this orbital is able to hold 6 electrons, so we can put 2p6. Down to the next row is 3s2, and then 3p6. And then calcium is in the 4s orbital, and it'll just be 4s2. And you can see that potassium is right beside it. So we can also just write similar electron configuration, except it'll end in 4s1. Okay, so the question asks, why do we believe that their valence electrons resides in the 4s instead of the 3d? So this is because their 4s orbitals are lower in energy. So typically for transition metals, sometimes your 4s can be lower than the 3d orbital. But for both calcium and potassium, the 4s orbitals would still be considered lower in energy. Okay, so the junior tutor said that from the Aufbau principle, electrons fill in order of increasing energy in the orbitals. S, P, D, and F are also part of the increasing energy as F goes to P, to D, up to F shell, which is the highest among the 4. In the case of transition between 3D and 4s, the diagram for their energy level is that 4s is somewhat lower in energy than with the 3D orbitals. Thus, this made the electrons fill up the 4s orbital first before 3D. Yep. So this solution is correct.